everybody. My name is Constantine Drulias, and I'm a senior environmental engineering student. I'm currently in the BSME program, which allows me to take master level courses while I finish my bachelor's degree. I graduate this spring with my bachelor's and will graduate the following spring with my master's. I transferred to UF my junior year, and the following summer I conducted research on electric train systems in Madrid, Spain. Last summer I was stuck in an unfortunate situation due to COVID and could not land an internship. Due to these past 2 summers, I have not had any engineering experience besides academics. This has led to varying opinions of what I want to do when I get out of college. I am excited to see what interest this course and paper reveal. But enough about me. Today I will be proposing an evaluation of mercury cyanide absorption from water aqueous solutions using granular activated carbon. The main form of mercury cyanide pollution to the environment comes from gold mining activities. Mercury and cyanide are common chemicals used to process gold in an inexpensive way. As seen in the flowchart, the first step to this process is called amalgamation. This step requires an individual to combine liquid mercury with an ore to create a solid amalgam. An amalgam is simply an alloy of mercury with another metal. The newly created amalgam is then heated to distill the mercury and recover the gold. The process is significantly inefficient and only recovers about 30% of the gold. Because of the first process's inefficiency, cyanide is introduced to the amalgam to recover a larger proportion of gold. The gold-rich and mercury-contaminated amalgam undergo a leaching process using cyanide. The second process is much more efficient by extracting 90% of the gold from the ore. During the process, mercury cyanide is formed and present in the wastewater. The wastewater is often discarded and ends up in local waterways. Releasing these chemicals into the environment have significant effects on the health of the surrounding environment. When released into waterways, mercury is known to bioaccumulate with aquatic organisms and humans. The main health effects are shown in developing brains of children. Gold mining processes using mercury and cyanide are common in underdeveloped regions. These regions often subject children to work at a young age, which exposes them to these harmful chemicals. In children, mercury affects their brain development and can have significant consequences. In general, mercury exposure can cause harmful health effects to an individual's nervous, digestive, and immune system, as well as affecting their lungs and kidneys. Cyanide exposure has fast-reacting health effects due to its ability to deprive cells of oxygen. Cyanide can affect the heart and lungs shortly after significant exposure and can cause death. With significant health concerns, I'm evaluating the effectiveness of absorbing mercury cyanide from wastewater using granular activated carbon. Granular activated carbon is a common treatment method for absorption of organic and inorganic contaminants. It is made from raw organic materials such as coal and coconut shells. Heat in the absence of oxygen is used to increase the surface area of the carbon, which activates it. Granular activated carbon's efficiency of removing mercury cyanide complexes is mainly dependent on the amount of surface area exposed to the wastewater. It is also dependent on the duration of exposure. Mercury cyanide is stable in the environment and is relatively difficult to remove without activated carbon. Granular activated carbon follows a chemisorption mechanism with mercury cyanide. Chemisorption is achieved by substantial sharing of electrons between the surface activated carbon and the different mercury cyanide complexes. Mercury cyanide proposes serious health concerns for underdeveloped regions, and I'm excited to learn methods to reduce concentrations of mercury cyanide in waterways. In my paper, I will methodically research and present different variables that can make mercury cyanide removal more efficient. My main focus will be how different activation rates, surface chemistry, and types of activated carbon will affect its efficiency. Exposure time of mercury cyanide with activated carbon is also a significant variable that can affect the efficiency of removing these chemicals from the environment. With any proposal, I'm going into this paper with many questions. The applicability of activated carbon has been the greatest challenge so far. Mercury cyanide gold mining is already illegal in many different countries, and locating potential polluting sites will be difficult. As seen in the photo in the bottom left, mercury cyanide pollution is often done in open waterways, which makes containment difficult. Mercury pollution to the environment comes from different sources. I will dedicate a section that applies granular activated carbon technology to other pollution sources. All in all, I am excited to learn more about this technology and how it can potentially improve the health of humans and the environment. Thank you.